All right. I think we are live on it's very media. So good early morning, afternoon, late afternoon, evening, night, whatever, everyone. Welcome to what's going to be a fascinating discussion on one of the topics that should keep awake a good part of our industry in the coming years, namely, and as you would see in front of you, our webinar on software-defined satellites meeting software-defined ground. I wish we had like 8 hours to deal with it. We'll try to cover most of it in 1 hour. So very happy to have you here to this kind of first Constellations so-called initiative brought to you and led by Kratos in partnership with Euroconsult for today. So I'm Pacom Revian, Euroconsult CEO, and very happy to take the responsibility of hosting the session of today. Can we go to the next slide? So I've been tasked as well. I'll be very structured here. For all of you who have attended some online events in the last year, for the attendees, so it will come as no surprise as an attendee, you will be in listening mode only during this session. However, we certainly look forward to having an interactive exchange. So you have the chat panel where you can send your questions on the fly, and we try to take some of them during the discussion or at the end of the initial part. So please send all those questions to the organizers and panelists that may be the choice by default in your box. The recording of this session will be made available to all attendees after the webinar. Presentation will also be made available, and for technical support, contact GoToWebinar, or if it's really that your internet is down, contact your local provider, I guess. Anyway, I hope there won't be any issue in the next hour for any of you. Next slide. So, well, today really we'll try to have a look. Well, I don't know if it's 360 degrees, but clearly we can have a broad view at that topic of software-defined in space and on the ground, looking at some of the market impact for our industry and the different stakeholders. Operational considerations, as it's certainly a major change for the operators of infrastructure in particular, but not only, and a future vision opening to what our industry may look like in this new environment down the road. And as said, welcoming your questions either on the fly or at the end of this discussion. Next slide. Okay, so you could see us on the screen. So I'm really very delighted to have no one will contradict me. I think three of the most knowledgeable, brightest minds and persons in our entire industry. So very happy to have with me today Bruno Fromont, Chief Technology Officer of Intersat, Antonio Abad-Martin, Chief Technology Officer of Hispasat, and Stuart Dosbridge, VP Advanced Technology of Kratos. So welcome to the three of you, and thanks for participating to this session today. Next slide. As we go to the constellation, introduction, just to mention, the Kratos team shall certainly tell much more about it and speak much better about it. But this constellation session is one of a series that will be proposed to you. It's the leading number one, industry podcast on space and satellite innovation, and for sure today, I think we have more than 500 people registered, so it's really the place to be on this Thursday of September, 1st of September. A lot of interviews there, the latest trends, technologies, really looking at breakthrough innovations, revolutionizing really our industry. And as mentioned, today, the first of the webinar series focused on space networks. Next one. Okay, keeping it even shorter, Euroconsult, I'm very happy to be here with you today. So as a company and having organized this webinar prepared this webinar with the kratos team, we have been providing market intelligence, consulting, advisory, organizing executive summits, in particular the World Satellite Business Week, and well, more recently added a large portfolio of training, actually, solutions to the industry. So very proud to have clients all around the world, and so to be discussing with those speakers today, and to have attendees from all around the world to this webinar. Next slide. Let's, I think, now move kind of straight to the topic, and having just a couple of really introductory remarks on my side before letting the mic to our speakers. So software-defined network, and to a certain extent it covers our discussion of today, where it's really kind of an end-to-end thinking, obviously embedding the space part and the satellite and software-defined satellite, so-called, but also the ground and all the components, let's say, that can make the new experience and the use of satellite-based solution much more flexible. So obviously, I could let our speakers comment on what they consider as definition or corresponding to software-defined network, but essentially, through the digitization of the payload and obviously changing the process, automated operations, new pieces of software, and so forth, it's about bringing really new flexibility. Would it be at capacity level, power distribution, coverage, obviously, of the assets, and having a much more dynamic management being enabled to serve various clients and operate the networks, while obviously may cover it. Certain constraints, and happy to hear about it, will still apply, because still operating a network is contingent to certain aspects such as spectrum or some regulatory constraints, etc., which has been the case and will remain the case in our industry as any connectivity sector. Next slide. Okay, so to really get closer to our discussion, if we just have a look back, and there can be different ways of describing the industry, but it's quite a fair statement that the industry has partly moved in steps, moving towards higher capacity assets and networks in the last decade, and more than decade, but really jumping in the so-called HTS design, a kind of a breakthrough to enter into broadband type systems and the broadband era. But clearly, we have shifted from an initial part that was a lot focused on the high throughput and replicability of spectrum, etc., to an era where this has to combine with a much higher level of flexibility to really go to the next level of optimization of the assets and have more capacity, let's say useful capacity, brought to any given asset and flexibility in their use. So as we could see, software-defined satellites in particular are pretty new. There has been flexibility being introduced on systems, at least partially, first digital channelizers, etc. But so-called really software-defined satellites are really starting in this decade, I would say. First assets have been ordered already and are to be deployed in the sky, except for, well, first one launched this year. And for the constellation, it's quite the same. First generation of obviously very different designs, some of them more or less flexible. But as we think of the next generation of kind of an interim phase beyond 2025, the move towards software-defined asset seems pretty clear. Next slide. So if we have a look at the geos themselves, and just trying to give some numbers, so it depends a bit on which satellites we qualify as software-defined. And in the year 2020, there was the question of the C-band repurposing process in the US that triggered the order of the number of geo assets. But if you look at those actual phases, a number of satellites already had some of those flexibility features, essentially from 2015, 16 as years of orders. But really, if we look at 2019, 2021, and even if you were to take an average, it would now be at least 50% more or less of the geo assets that would be considered as procured as software-defined satellites, depending on the mission. So when we say that it shall not be all of the assets, but it's really becoming kind of the new normal or the new, well, reference thinking as it seems for satellite operators, at least, which shall be addressed. And next slide. And I think that, yeah, more or less, almost the last one. Okay, to start with the discussion on the new opportunities, coming with those new procurements, we believe, we hope, but that the industry, there's no shortage in terms of appetite for bandwidth. We anticipate traffic over satellite networks to, well, can be various assumptions, but multiplied by maybe 5 in the next 5 years at least, if not more. While obviously, as in any broadband industry, the cost of the data, the cost of bandwidth, how much you will pay against how much bandwidth capacity you will get, will kind of continue to go down just as we have fiber on the ground or 5G, etc. That follows quite the same trend. And we anticipate that actually most of the data-centric segments at least should grow in the coming years. So there can be different speeds or rates of growth, but all of them shall grow. Will it be access at large to mobility, enterprise, or defense? And this coming with the question of how much is actually the role of the satellite operators, but certainly as much the question of the service integration. And on the next slide, already too far. And this goes to the question of actually how this will change and how it will change as well the organization of the ecosystem or the role of the various stakeholders in our industry. So I think, Pauline, we can stop the display for now, and I've spoken already far too much. So in that context, and turning to the three of you, and again, welcome. On that question of software-defined assets and networks, obviously, it's done because there's a purpose and there are benefits and benefits for the client's orders. So if we are to think on the applications, use cases, and so forth, where that new approach could be most beneficial, or actually absolute new business opportunities that may not be possible without it, would be happy to get your first thoughts on this pretty large question. Maybe Bruno, if you would like to comment on your view on that SD dynamic and those use cases.
Sure, thank you, Paco. So before I answer, maybe as you presented in your slides, I think it's important to understand that, as you said, it's a new technology, but it's also a continuity of something that started, some time ago. On our side, we have, strived to put new digital technology on our assets, back in 2016 and even earlier than that. And I think, with this technology hitting the market these days and this year in particular, I think it's more profound than just, a new technology, a new capability that will enable new application. It's a sign of our industry coming of age. There are two really levers for our industry transformation. I think one is 5G, and we can talk about, about it later. And the second is really, the advent of software-defined capabilities, which brings us on par with the broader ecosystem, which gives us the capacity to scale up. And this is the primary, driver for the benefits of software-defined, technology in space or ground assets. So from that perspective, what software brings, and there were, I don't know if you recall this interesting article from Mark Andreessen in the Wall Street Journal. I think it's back in 10 years ago. Why software is eating the world, right? With software, we begin to change totally the dynamics of the life cycle, the procurement of assets, how fast you can deploy services, which will benefit all customers down the road. From that perspective, all applications benefit. If you look at the backlog, the pipeline of orders so far, it's just starting, right? From Airbus. But I mean, there are operators that will use the asset in a very traditional way. But the prime benefits of a software-defined satellite are also for the manufacturers to begin to shorten the manufacturing cycle, so ordering quicker, and also by reducing the components, propose a lower capex solution for replacement of assets. So from that perspective, many operators will just want to benefit from lower cost and replace their existing assets with software-defined payloads. And at the same time, because of the flexibility, I think they will buy an insurance on the market. Basically, if things change, coverage, frequencies, things can be adjusted, in the future. And that's a good peace of mind and flexibility for their customers. So I think the market is good, for media application. I think Optus ordered a satellite, and they plan to use it also for some media application, JSAT as well. Obviously, because of the dynamic nature of these payloads, where you can really deliver capacity where you need it and when you need it. For us, we think that the application that will benefit the most would be obviously mobility, where the demand is changing all the time. Devices, terminals can benefit from the fact that the utilization of the resources are maximized, followed by government applications. But frankly, all applications will benefit from shorter cycle, lower capex down the road.
Come, you're muted.
Yeah.
Sorry. For that. That's the beauty of time and speaking. So, Bruno, from your comments, I also get the question of the predictability of the market. So clearly, mobility is changing all the time. So there are obvious patterns. When thinking of what happened with COVID last year, where people have started to work, use traffic, etc., could be quite interesting with smaller coverage beams, etc., to see where actually traffic has moved in some cases. And Antonio, with that, I think it also comes to the question of definition of the assets. Obviously, I think for operators, a challenge in recent years has been, okay, the question coming back and again is, okay, 15 years asset, pretty complex if you can't change the mission, how to make a decision, where is traffic today, or, well, 5 years from now, in a 5G environment, etc. So, is it really so changing the game, in your view, to address application and your thinking of yeah. Antonio? I don't see if you're muted or do you hear me? Yes, maybe, or give it a try.
I was muted by somebody. I was muted by somebody. Sorry, fine. So thank you, Pacom, and thank you to the organization for inviting me at this to this exciting chat. And I would like just to lower a little bit the expectations of the audience, at least on my participation, because I have to recognize that, as you have very well mentioned, there is no experience, there is no satellite, no full software satellite in orbit today. So it's we are. I mean, at least on my side, I'm talking on speculations on what I think.
No, yo prefiero cambiar. Ya veremos cómo manejamos la situación de esos 6 minutos. A ver si hace mucho o lo deja, no sé, ya iremos hablando. Yo por ahora les contesto lo que habíamos hablado.
There is some interference.
I don't know. Someone spoke, but no idea who that person was. Quite surprised.
Yeah.
Okay, move on. Yeah.
Yes. Sorry for that. So I was just trying to add something to Bruno's Bruno's response. Essentially, recalling that software satellite or digital flexible satellites have two main advantages, as you have mentioned. One is flexibility, and you have mentioned about the adaptation to the market. But I would like also to mention that the capability of this flexibility to facilitate the dynamic resources allocation that allows to optimize the use of the payload. And it allows, as we will probably discuss later, it allows to make a more efficient use of the payload, and probably to increase the revenue that you can obtain with the payload. But I wanted also to mention about the ability of these software satellites to be reconfigured in orbit, what allows for the definition of standard recurrent satellites that can make use of standardization and industrialization techniques that will certainly decrease the cost of the capacity. So I think that that is also a very interesting capacity of these software-defined satellites. And in terms of the application that will be benefited, as you said, most of them, but most likely all applications where capacity is time dependent could be very well benefited from these software-defined satellites. And you've mentioned aero mobility, but I would like to mention, and it's not something that it is very well done, is not very well implemented today, but I think that internet access, it's also an application where there is a daily pattern profile where the people is using the internet access at certain hours of the day, and the combination of those patterns with other patterns of capacity consumptions could be making a very interesting use of our payloads in the future.
Yeah, it's actually a good point where you could try to, well, find other applications working at different hours, expecting that all of them don't have the same peak time. That's a good point. And actually, maybe to work with those new applications, and before jumping on a question of business model, Stuart, on some of the implications for the ground, maybe you could share some first thoughts, because obviously having dynamic assets implies to have a dynamic management of this to make it happen and to react to, well, there's the control part, but even user requests and the rest. So how do you see some of the implications for the ground? And happy to have Bruno and Antonio further commenting on this.
Yeah, that's a great question. So one of the things, you know, looking at your chart, Pacom, that I noticed was that all of the growth markets you show are IP transport markets. And I think that goes to the, you know, coming of the age industry, as Bruno said, that's really, you know, IP transport is really the issue now. And the IP transport market, the fact is it's a dynamic market. You know, kids download videos. It's not a constant rate market, and therefore you need to be able to dynamically adjust your network the way the terrestrial guys do to the demands of the market. And that's the only way to drive efficiency into your operations. And I think as an industry on the space side, we've done a fantastic job with software-defined satellites that now are starting to give that capability to be able to be responsive to that. But I think we still have a long way to go on the ground side to create a software-defined ground that allows you to really monetize and take full advantage of that capability that you have in space. I mean, if you look at the terrestrial guys, like right now, if I called up my internet provider and I asked him to change my level of service, it would literally happen within minutes. And that type of dynamic service capability is something that doesn't exist yet in the satellite industry. But if we're going to play in the wider IP transport market, we have to play by their rules and be able to support their dynamic operations. And so I think that drives you to software-defined grounds. It drives you to virtualizing your hardware infrastructure into software VNFs. I think it drives you to orchestration systems to control that software so that you can rapidly deploy and respond to services. And I think it drives you to cloud-based infrastructures where you can get scale up and scale down and get the resiliency that cloud offers. So I think it drives you to the software ground that's got to match up to the capabilities that the software-defined satellites offer.
Thanks. And maybe, Bruno, rebounding also on the topic of orchestration or network management, you touched on 5G earlier, as obviously pretty next on the horizon for the industry and to have a major impact in the course of this decade on the ground and for the satellite industry. So would you consider that this move to SD satellite, but also potentially ground, is kind of a condition for the industry to, let's say, be fully compatible or to benefit from the opportunities that will exist in 5G?
Yeah, I think it's a combination. I think Stuart is absolutely right by saying that the ground infrastructure and investments have been lagging. As you build and deploy software-defined assets, you need to match your investment on the ground if you want to fully take advantage of the capabilities of what you have invested in space. And in our industry, it's striking to see that the ground ecosystem is made of doesn't have maybe the scale, the financial capabilities of what we have on the mobile operator side, which brings us to what 5G has been developing over the years. And 5G is unique because for the first time since the December 2019, non-terrestrial network have been integrated in the release of the standard, which means and brings the promise of in the future having the ability to leverage chipset made for the mobile industry into the satellite industry. That's one. Second, benefit from all the software back office. Stuart talked about orchestration of the different network elements, which comes at a standard in let's say in a 5G core, can now be used to manage satellite systems or networks end to end. That's a big big advantage because again our industry is $12 billion in FSS at least, and in one quarter AWS makes the same amount of money. So the cloud, the scale. I mean, we need to tap into what's being done in the mobile or cloud ecosystems and integrate that into our networks, and it's a great opportunity for us.
You're on mute.
Sorry. Okay. Yeah, just finishing on that before entering into the operational kind of focus on the business model, and maybe on Antonio you could start commenting. So obviously the industry has seen some level of vertical integration lately, and I would say one direction we touched on CapEx. One direction to the industry is about optimization as for the entire, let's say, ICT industry. When I think of previous generation assets, in particular moving to broadband or HTS or some fixed design, you could think of some satellite networks reaching maybe a maximum use rate of 70%, depending on the case-by-case basis, design, coverage, everything. Out of that, you could have clients. Those clients themselves may have capacities. They do not always entirely use it. So out of that, you could think of network and spectrum. And from the start to the end, and with those peak rates, maybe you're using, I don't know, maybe just 50, 30% of the resources you have in the sky. And obviously, well, spectrum, everything is scarce, and data requirements are high. So it's about making everything work together. So just on that part, to give a sense of the form of type of optimization you could think of, but also whether you think that it may further accelerate the integration of the role taken by the satellite operator in the ecosystem, just because if you control everything, all the traffic, you change the mission all the time, does it change the role itself intrinsically at some point of the satellite operator, just because of the technicalities, let's say, of it?
Thank you. It's a very wide and complex question. Thank you for that.
All good.
Let me try to answer at least what I think I can answer. I think that you are referring to two different kind of integrations. There is one integration that is the integration in the value chain, and trying to be very open and clear. I would say that I don't see a priori any acceleration of the integration of the value chain because of the software-defined satellites. But however, if we are talking about the integration with the terrestrial infrastructure, I definitely believe that this is going to accelerate this integration. I think Bruno and Stuart have mentioned clearly this IP world that we are living today, where the connectivity is the key service, and I think that we are a very small portion of the terrestrial infrastructure. We are like 1% of the terrestrial business, and certainly the integration of the satellite into the terrestrial infrastructure will allow us to benefit from these capabilities. Because at the end of the day, what it is very clear, and it should be very clear to all of us, is that the user doesn't care on whether they are using satellite or terrestrial or whatever. The user wants connectivity, and the role of the satellite in the connectivity world will be to provide connectivity in a seamless manner with the other 99% of the connectivity providers, that is terrestrial. So the integration with terrestrial is key and paramount for the satellite future, and I think that the software satellites are providing us a good opportunity for improving this integration.
Thank you. Any further comments? Well, actually, I happened to spend the night in an hotel without even 2G connectivity in the middle of France in August, so I know there's room for some more connectivity even. Yeah. Maybe before moving to the personal, maybe one point. So also on the ground segment, economics or model. Obviously, if we move to software-defined in the sky, but also on the ground, the kind of relationship, the hardware part of the software as a service portion in the relationship, I would say, with the clients or partner in the industry, is it something where you expect to see changes as well with that trend?
Yeah, so I guess two things. One, just to add on to what Antonio said, I think what we have to start realizing and thinking about is that in the future, we're not selling transponders like we were in the past with bent pipe satellites. Future satellites are way more like, or software-defined satellites are way more analogous to a network switch in the sky. And we got to think of it as a network device in the sky and start treating it that way so that it's an integrated part of a wider network. And I think that's how, we take the industry to the next level, because, then we start thinking about how do we tie in better with terrestrial, how do you operate that network switch along with the ground infrastructure in a coordinated manner. I think that's the mental shift that you have to make. I think to your question about business models and as you move to software-defined ground, moving to software from hardware to software absolutely opens up a lot of opportunity on the business model side, because now there's no large capital expense that you have to make up front. You can buy software as you consume it. And so whether that's a ground system as a service model, a pay-as-you-use model, it opens up opportunities to change the business models for the ground system providers, but also for the satellite operators, because it changes their, how they can consume the ground and tie that the cost of the ground way closer to the cost, to revenue generation. And therefore, it takes some inefficiencies that existed in the market when you had hardware hubs and line cards that weren't fully utilized, but you had to build out the infrastructure when you first bought the satellite, so you had coverage in all your regions. You created a big, large inefficiency, and you can remove and take a lot of that inefficiency by going to a software-defined infrastructure.
Stuart, I will.
Thank you.
Yeah. Sorry, Paco. I wanted to comment on what Stuart and Antonio have done on the business models. I totally subscribe to the recent comments. This scalability is really key. I mean, we are investing right at $2 billion on our software-defined network, space, and ground. And so what we see is exactly what is being described, which is the ability to license functions or virtual functions on the ground teleports, and spawn a new instance when the traffic grows, or reassign computer resources somewhere else based on the demand is a tremendous asset for operators. And this will translate into new services for the end users, like this, from long-term commitments to more pay-as-you-go models, which will be very efficient to run. Before, it was really difficult to assign this, but now this is something that can be translated into the marketplace. And maybe one last comment on the fact that I do believe it will have an impact. It has already had an impact on the ecosystem and the service providers, moving to the satellite as a node in the sky. And clearly, even if the service providers survive or adapt, they will have to adapt to that new technical equation, maybe moving the line of separation between what they sell versus what the operator is selling down the road. Right now, we could see the COVID crisis, exemplified, how fragile the service providers have been. Look at all the restructuring that happened on the service provider side because they had to overcommit wholesale capacity that they have to resell. It's very inefficient. This can now happen very quickly. And I think we need to cure that inefficiency between the people that deliver in the marketplace and what people that build the networks like ourselves. We acquired Gogo for a reason. I mean, they were fragile, and there are others as well that that may be impacted by redrawing the line of separation between what is a service and what in the marketplace and what is providing the network capability. So that's going to have some lasting impact, I think, and I think it's healthy.
Yeah.
So,
Antonio.
Yeah, just to complete the answers on the ground segment, it is always very good the pay as you grow scheme and changing capex by opex and aligning the revenue with the expenses. But something I want to highlight that is important also is that in the connectivity business, we have changed the mix of capex that we had in the past. In the past, the ground segment was a very little percentage of the total capex in the program. And nowadays, in connectivity programs, ground segment is the third expense that we have after the satellite and the launcher. So it's not only that it is good to align, is that we are now putting a lot of focus in the ground segment because it has become a very important budget in the overall capex program.
That's quite an interesting point, and I shall just remind you to delegate that they can ask questions. I think the question box, so I'm keeping an eye on that. So any questions welcome. I think that's a good transition to some aspects of the operation. So when we think of the traditional life cycle, that it's about procuring obviously the satellite at the ground you just mentioned, and so forth. Maybe one, if we think of the procurement itself, I may still have a couple of questions. So, do you believe it will change that kind of cycle or duration to decision making, or maybe the number of assets to procure, or kind of the fleet management dynamics, let's say. And maybe just a side question about those assets. Obviously, we mentioned already about standardization. It's always a question of what's standard and what's a bit of a proprietary brick or software that, okay, that's fine. I have a fleet, I have 10 software-defined assets, but from different bundles. So is it then on the ground or overlaying software that will have to make that work together? So happy to have some thoughts you may have on, okay, how it changes the thinking on the procurement approach, and some maybe challenges you see or things that you still are going to continue, are about to evolve in the next 2-3 years, but still, pretty early days for those new assets in a sense. Bruno, Antonio, any thoughts?
Well, as you know, it's well known we have ordered 2 software-defined satellites, and it's known that we have an RFP out for more. So it's probably changing a little bit, the appetite, as I said, for risk, because of the risk mitigation inherent to the technology in the way we think about fleet replacement. Of course, it comes at a price. We are so used in this industry to have our bespoke solution, spending years defining what the mission of a satellite will be. I think the time will be spent elsewhere. It means also the differentiation will be not made necessarily on the satellite capabilities, because let's face it, if we have a lower capex and more faster time to build and put in service, we're going to lose on the tailoring of the mission to a specific geography or orbital location and so on. So that's okay. We will have to deal with that over time. I must say that it may also trigger broader cooperation in the sense that assets being more standards, we can procure and pool capex resources between operators to build the infrastructure and spend more time on the market differentiation, go-to-market strategy, the kind of product that are delivered based on the ground technology, and that I think is a positive for the industry. I mean, again, if we talk about scaling up and our ability to deliver bits to consumers, we have a lot to do and lots of investment to catch up to match the terrestrial guys, right? So that's a positive in my mind.
You're on mute, I think, Antonio.
Okay, now I am unmuted. Can you hear me now? Yeah, I was saying that. Hello?
Yes,
you hear me?
That's good.
Okay. No, I was saying that exactly. I mean, the difference is that we'll be moving from tailor-made satellites to standard recurrent satellites, and that will imply certainly shorter schedules, because at the end of the day, they're going to keep building the same satellite. And I think that will also give the opportunity to manufacturers to learn from constellations. I think that everything related to the industrialization of the satellite manufacturing, that manufacturers are learning, because they are building 200 or thousands of satellites for constellation. To some extent, will be extrapolated to these smaller series, but to this series of GEO software-defined satellites that will make use of this industrialization. And I think that this will also lead to a different testing approach that will simplify the process, and it's something that we will have to discuss with the manufacturers. So there should be an involvement of the operators with the manufacturers in this definition on the new standards for testing some recurrent satellites. But I think that this will simplify, and it will also help in shortening the development time and the manufacturing time for our satellite. And last, there is an interesting opportunity for manufacturers that is investing in stock. So at some point in time, manufacturers may decide to build their own satellites just to put them in their stock, so that you could have the opportunity, a satellite operator could have the opportunity of buying a satellite a recurrent satellite that is in storage, and have it in orbit in question of several months. So there could be some interesting changes in the market that could be derived from these satellites. And I think this is an interesting one that satellite manufacturers surely will analyze in the next years. Just to finalize, you were talking about standardization. I don't think that this is going to drive to any kind of a standardization between the different satellite manufacturers. So I think that each satellite manufacturer will have their own standard recurrent satellite, but it will certainly simplify the process, and we will, satellite operators will maintain the possibility of making compatible, will have to make compatible the operation, and this will be a challenge, maintaining compatible the operations of standard recurrent satellites from different families, from different manufacturers. I think that this will be an interesting challenge, and it will give a very good opportunity to third-party ground segment suppliers, because I don't think that the ground segment to control the payloads of those satellites will be finally made by the satellite manufacturer. We will require third-party, because we will require somebody that can integrate a satellite built by Airbus, with a satellite built by Thales, with another one built by Boeing, and all of them working together as a single payload, where you can allocate capacity in a very dynamic way from one satellite to the other one, and do that in a very transparent manner. And this can only be done by a third party that should learn from the different manufacturers how their software-defined satellites are working, and how they can interact together, because this is at the end what the satellite operators will be expecting from them.
Okay, well, maybe Stuart, you have further comments on that. Actually, if you would expect it to change a bit the topology of the ground segment, the ownership, and ground segment as a service is developing very quickly in EO, maybe more difficult in SATCOM today for various reasons. But also that question of making those software-defined satellites work together actually, and optimize it as a fleet or pool of traffic, if I say so.
Yeah, no, I think Antonio brings up a fantastic point. That you are going to need to abstract the satellite uniqueness from the different manufacturers away, so to drive operations efficiency for the operations group. Just as has happened in C2 systems and other systems in the past, it will need to happen with the payload control, because payload control now is going to be an integrated part of your network. And so, that's a huge issue. I think one of the other issues that I would talk about with that is that if you start thinking about, you're going to have a software-defined satellite that would allow the satellite portion of the network to be updated, let's say every 10 minutes. Therefore, your entire ground planning process now has to run at a cycle for your payload that runs at that speed. So you need to be able to take a service request and process it and replan and reconfigure your satellite in 5-10 minute cycle times, whereas in the past, that's just not how the satellite industry has run. And so, because having a satellite that can update every 5 minutes and having a ground system that can deploy services on the fly is great, but if your planning process takes 3 hours, it really limits the value. But on the flip side, when you start driving to that level of automation, all of a sudden you can drive other efficiencies into your your operations, because now you can not only optimize on services, but you can start optimizing on weather and stop optimizing around interference and things like that. Because, if your planning cycle is now every 10 minutes, well, it's pretty easy to know what the weather is going to be in 10 minutes. And therefore, you could apply power and bandwidth where needed to overcome weather issues. It would also allow, again, looking at a satellite as a network switch and being able to reallocate the resources around. Right now, the industry typically holds margin at a service level. And so now you could actually move holding that margin up to the satellite level and drive greater efficiency, and basically be able to drive greater loading in your satellite by holding margins at the system level and reallocating on the fly. So I think there's a huge number of advantages that come, but it requires significant automation of the ground, of that whole ground processing cycle, from service request to changing the payload in coordination with changing your ground system to the changing demands of the services. And then on top of that, you need to add the issue that different satellites from different manufacturers will come with different capabilities, different tool sets, different management tools to deal with that you'll need to integrate in and abstract away from your higher level planning systems. So yeah, I think there's a lot of challenges that have to be addressed on the ground, but I believe the opportunities that they drive are massive for the industry.
Thanks, Stuart. So I see time is flying already. I just seeing a number of questions out there, so I try to combine or throw a number of them, and happy to get kind of short answers to you. So maybe the first one, if I try to combine at least three of them, maybe 1 point. So just a few years back, flexible satellites or software-defined were fine, but more expensive. So, okay, it could be great maybe for a few exquisite clients, but the economics of it made it difficult. So you would, you've ordered some, so would you consider that now, with the new economics and what you gain, some of the costs you may have, so it's now really the kind of the most cost-efficient approach? A second one is, okay, in that case, is your view or is the general view that, well, I will need fewer satellites because I can optimize so much so that, 3 satellites will be 1 or 2, whatever, or that there will be as many or maybe even more because of the new cost balance or the new efficiencies? And out of that, okay, if there are fewer satellites, do we need as many vendors, or do you expect some impact on the number of vendors that would be required, at least for geosystems? So it's not necessarily from me, just throwing that to you as a package. So kind of, okay, the economics, or let's say attractiveness of it as a product or solution. Then more assets, fewer assets, as many, and okay, on bundles, if it's getting more and more standard, lower capex and everything, with maybe a shift toward ground, okay, any impact you would expect on obviously the manufacturing front? Bruno, Antonio, even Stuart, happy to get your thoughts.
Well, let me give it a try. It's a vast question, of course. Obviously, the economics of these investments is at the forefront of our strategic decisions to pursue that path. My current assessment, and I think maybe we can start with where Stuart has left us with the optimization of the network and what this brings. If you look at the past 30 years and you look at the history of the satellite efficiency from how you transform spectrum into bits in the most effective manner by progressively increasing the satellite power, the efficiency of the spectrum transformation. And there's one single factor that has been driving the capacity and the capability of this industry, which is frequency reuse. That's the best way. The the spectrum and the bits have been, capacity of the system have been increased. Some of this capacity reuse, actually, when you look at the first generation of HTS, it was on one of your slides. You're losing a lot of it because everything was fixed, not flexible. With software-defined satellites, I would say you would reclaim the full benefit of frequency reuse in time and space. And so this is really the next level of optimization, because now you can really allocate within the envelope of power, spectrum, and geography in an optimal way with the right software and all the ground capabilities that Stuart described. So when you look at boil it all down, I truly believe that software-defined, at least in geo, is as or more cost-effective than most of the constellations that are being deployed today. I mean, I can reiterate that multiple times. If people don't understand it, I will say it again. The geo model here is more cost-effective on a cost per bit, ground plus space, than the constellation that are being deployed. There are pros and cons and everything. So that's why I believe we will need both down the road. And this is how far we have gone in terms of cost effectiveness. So I think this is, there's no doubt in my mind that this is a model we can deploy. And for that reason, I don't see that we're going to necessarily reduce the number of satellites in geo. There will be more, maybe constellation and compatibility, multiple networks. But these satellites don't have necessarily a massive amount of capacity, but they are super efficient. So I actually see, more deployment, replacement, fungibility of the resources by moving them from place to place down the road. So I would say that in geo, it will be a status quo or even better, because let's not forget the demand keeps growing, but we'll have better cost and we need to match the demand from that perspective, from a pricing perspective.
If I may, very, very quickly, I want just to reinforce Bruno's argument. I'm fully in line, and I fully agree on what he's saying, that the capacity, the cost of the capacity of this software-defined satellite will match or even be better than the one that they are proposing for the constellations, with different capabilities that certainly will make it complementary one to the other, but certainly agree with that. And I wanted to recall something, that is that I've spent the last 15 years discussing with manufacturers about flexibility. And it has never happened, because I explained during 15 years that they were taking the wrong approach, giving flexibility for a more expensive price. The difference this time that will make it succeed is that this time we get flexibility for lower price. And I think that this is the key success factor for the software-defined satellites.
Okay, I'm just trying. We're already at 6 p.m., so I'm trying to see if there's one question I could take, but maybe Stuart, on your side, and coming back also to the ground segment and the cost of it, I think, if we talk in that context about the virtualization of the ground segment, so the ground segment, even at large, will be not always so obvious from everyone, from the antenna to the RF to the modem part and so forth and after. So when we think of the virtualization, obviously it may not necessarily happen exactly in the same way for the different parts of the ground segment, shall it? Or how do you see that transition to software-defined, whether it's an end-to-end solution or by step, or how do you see this evolving in the next few years?
I see it happening probably when satellite operators buy new satellites. That's when they will look. It would be it's hard to transition an existing legacy system where you've already invested in the ground infrastructure. So it would be very hard to transition that to a software-defined system. So I see as new networks and new satellites and new software-defined satellites are procured, I see that's the opportunity to inject the new software-defined ground technologies and capabilities. So that's how I see this transitioning. The one other point I did want to make, it's a little off topic, but is that I think the key to success in this digital transformation for the industry and for the growth of the industry is a move towards standardization. Antonio mentioned that on the satellite side. I think it's even more important on the ground side. And it's the adoption of standards that already exist, not the satellite industry trying to create their own for the most part, where they should be adopting like standards and 3GP standards, and where it allows us to integrate into the much bigger, as Antonio said, 99% of IP transports done by these other industries. Adopting their standards and being compatible with them only makes sense. And I'll make a shameless plug for the Digital IF Consortium that got announced yesterday. The goal of the consortium is, as we move away from analog signals that have a natural interoperability to digital packets, you have to define those packets in a standard way so that you maintain the interoperability the industry has always had at that point. And so that's what that organization is about. It's called DIFI, and the website is diffiorganization.org. So if you have any interest in digital transformation, please check it out. Thank you.
Thanks. I think just as Antonio mentioned about flexibility, having to work with lower cost, I think in what you said as well, innovation will have to work together with standardization. So the industry will need to find its path in this fast-moving environment. So I feel we have exhausted our so first comments. There are unfortunately a few questions we could not necessarily cover. So I shall see together with the Kratos team if on certain of them we can bring at least a bit of a feedback in writing afterwards. So it's something we shall have a look at. Before we close, I would give a conclusion or kind of the vision to each of our speakers. A reminder, if you can fill out the survey after the webinar that will come up on your screen, that will be much, much appreciated. I mean, the objective is that you this time has been useful to you, and that the next ones are, I don't know if it can be even better, but are as good as what we had as a discussion today. And as mentioned, you can view the replay if you want to see it 3 times during the next weekend as any hot movie. You can do that, or pass it to your connection. And for Constellations, you can sign up to email alerts, obviously, to receive the new podcast articles, online discussions. You have the address here. Maybe you'll receive something from Euroconsult, but we'll make sure to not overflow your email box, definitely. Bruno, Antonio, Stuart, if you had to give a bit of a vision of that software-defined direction or industry in 3 to 5 years. So Bruno, those assets are in the sky that you've already procured, or some changes you see there. Well, you may have 1 minute to share your one thought for the future and for our audience.
Who starts?
Starting. Well, Antonio, you started to speak. You can start.
Okay, so in 1 minute, but you will allow me that I won't be focusing in 3 to 5 years. Let me focus in 10 years. There is something that we have inherently exposed here about the integration of the satellite with the terrestrial infrastructure, and I would like to go to the long term, to go a step further in that integration. And I believe that there is an opportunity by the integration of these software-defined satellites using optical technologies that will interconnect satellite and satellite to ground. It will be possible to create an internet in the space where the satellite operators will become tier 1 providers that will provide capacity to tier 2 and tier 3 providers that will supply the capacity to users that will not know whose is the satellite coming from, and will be using this internet in the space as a service where everything will be merged in a single infrastructure that could be finally merge with the terrestrial infrastructure. So I believe that in the future, the space, the satellite infrastructure should become part of the real part of the internet and get fusion with the internet in the space.
Thanks for that. And I know that Hispasat is also involved in some initiatives around connectivity, maybe for the moon, so that seamless connectivity, maybe anywhere on Earth down to up to the moon potentially. Bruno or Stuart, to the next.
Just to piggyback on what Antonio has said and what I said at the beginning, I think we are witnessing a massive convergence. Again, I refer to 5G because it's within 5G you have networks of networks, but what we are talking about and what I think Antonio is talking about is the ability of these networks to interact with each other, that provide that scale and flexibility at a macro level between space, ground. Whether the space network disappears, it's just another way to route traffic, whether on the ground or in space. It shouldn't matter to the end user. And I think we're going to see a greater interfaces due to this 5G standard. I think in the future in 6G as well. I mean, I don't want to be too optimistic, but there's a lot being done, in terms of preparing for what's coming after 5G. But between mobile operators, the telcos, the space operators, and the end user, a better roaming, capability enabled by these standards and this technology. This is what we are witnessing. This is, in progress, and the economics make sense for everybody. So that's why I see it.
I think that if this is achieved in this decade, as Antonio suggested, I think that will be a very big milestone for the industry, for sure. Yeah, that's the direction. Stuart, you.
Yeah, so I agree with everything Antonio and Bruno said. I think just to add on to that, I think what will happen is, satellite in the past has always been special and unique, and that will go away. Satellite will just be part of the network, and it won't be seen as special or unique. It'll still be hard, but it'll be just another node on the network, and it will integrate in. And if you look at how satellites are used, the vast majority is either for communications or as some type of sensor. And now it'll just be that sensor or that communications, Ethernet switch or router is now in space instead of on the ground. But it'll just look and act and perform like the rest of the network.
Okay, I think that's very clear. Well, maybe not unique anymore, will be part of the, let's say, network of networks that's quite invisible, but I'm sure, and well, I expect the industry will remain vibrant and keep attracting a lot of great minds and workers and people who will contribute to make all of that happen, obviously, through the ecosystem. All right, I think we're already, 11 minutes behind schedule, so will be time to wrap up. Thanks for having stayed with me even longer than we had expected. Thank you very much, Bruno, Antonio, Stuart, for sharing your thoughts today. I hope that you enjoyed this webinar session, and we look forward, and I think I join with the Kratos team to wish you a great day, evening, night, whatever time it is for you, and there will be more news on the next Constellations webinars, among other things. So stay tuned. Thank you very much, and have a great day.
Thank you.